Alright, hi, Mr. Cole here, and today's topic is powers of 10 and the scientific notation. So, we've got a pretty packed schedule today. So, our goal for today is we're going to evaluate powers of 10, we're going to write powers of 10, we're going to multiply powers of 10, then we're going to write it in scientific notation, and then we're going to compare numbers with scientific notation. So, we've got 5 things that we need to worry about for today. So, but a lot of it is very meshed in together, okay? They intertwine with each other. So our California starter for today is Algebra 2.0, and our vocabulary for today is scientific notation. And scientific notation is basically a method of writing really large numbers and really small numbers, okay? So let's get going. We've got a lot to cover. Alright, so first off, we're going to go ahead and just write this powers of 10, and we're going to write it as 1. Okay, so we're going to take this, we're going to write it as 1, and we're going to go ahead and move the decimal place as many times as the exponent is going to tell us. So if you look at it, we're going to move decimal right for positive exponent, move decimal for negative exponent, and then of course we're going to add zeros as necessary. Finally, we're going to go ahead and simplify. So here, let's go ahead and write it as 1. Now, that 2 tells us we're going to take this decimal and we're going to move it over right 2 times. Since we do not have any zeros right now, or we don't have any numbers, we're going to go ahead and put 2 zeros in here. So my answer of 10 to the second power is 100. And that makes sense because 10 to the second power is 10 times 10, and that's 100. And again, this is just another method to go ahead and solve your powers. But this time we're going to make sure that we're talking about the powers of 10, okay? And this is how it kind of works out. Here, we're going to write it as 1. That 0 is going to tell us how much places to move. Since it's 0, we're going to move it any. So the answer is 1. Pretty simple? Alright. So now here, we're going to go ahead and write it as 1 again. But if you look at it, I now have negative 3. Now this one was positive 2, so I moved 2 places over. I'm going to take this and move this over 3 times to the left. So let's give it some space. 1, 2, 3. So I'm going to go and put zeros in here. And there's my decimal here. When I rewrite it, it's going to be 0.001, or 1/1000. Okay? So that's the reason why we're writing it as 1, and we're going to move the decimal right for a positive exponent, and we're going to move the decimal left for a negative exponent. Alright, so now, the question that I'm going to ask you for this particular, example here is, how does the decimal with a positive or negative exponent move? And you should have gotten that by our examples here. Okay? Alright, let's move on. Okay, so now let's go ahead and reverse that. We're going to go ahead and we're going to write powers of 10 on this one. Okay? So we're going to go ahead and turn it back into its original. So we're going to go and count the place value from 1. So let's look at here, and we're going to go ahead and take our decimal here. So we're going to take the decimal here, and we're going to go ahead and go 1, 2, 3, 4, 5, 6. Okay? And so, for me to get back to 1, that's going to be 6 times. Because I moved this back to 1 6 times. So if the exponent is positive, and the exponent is going to be 6 because I moved it back to 1, that's going to be a positive exponent. Okay? So now, let's look at this. I need to make this 1. So I'm going to move this decimal over 3 times. So it's going to be 10, 3 times. And my original number is less than 1. It's a very small number, okay? It's 1/1000, which means my exponent is going to be a negative. Alright, let's try it with 10. I need to make this into 1. So I'm going to take that decimal that is here, move it over 1 time, and that's going to give me 1. I moved it over once. And then, is my original number bigger or less than 1? Well, it's bigger, so that's going to stay positive. Alright? So, real simple of how we're getting that exponent back to its power of 10. Okay? And if you look at it, 10 to the first power, it's still 10. Alright, knowing how we do this, how do you know if the exponent will be negative or positive when you write the power of 10? And so just by looking at what we've done here with our examples, you should have an idea. Okay? Alright, next one. Alright, so now we're going to go and multiply powers of 10. So first off, we're going to go and rewrite the original number. So here's 12. Second, we're going to go and move the decimal right if the exponent is positive. That's positive. And then we're going to move the decimal left if it's negative. So here, since it's positive, here's 12. Here's your decimal. We're going to move it right 3 times. 1, 2, 3. Put zeros. And then finally, we're going to go ahead and rewrite. This answer is now 12,000. Alright, so here we have our number again. So I'm going to write 0.163. And notice that it's a negative exponent. So I'm going to go and move the decimal left that many times. 1, 2, 3, 4. Place some zeros in here. That's my decimal placement. So my answer is going to be 0.0000163. That's my answer for this, because I am having a much smaller number than this. And then finally here, I'm going to rewrite again, 97.3. My decimal exponent is 2. Take this over, move it twice. Put a 0 here. My answer is going to be 9,730. Okay? So, looking at these 3 particular problems, when you're multiplying powers of 10, what determines if the decimal is going to move left or right? And you saw how this moved left, and you saw how this moved right. So looking at your exponents, so that should give you an idea. Alright, so we're almost there. Okay, so now is the final part. We're going to go and work on how to write in scientific notation. So first off, we're going to go and rewrite the number. And we're going to move the decimal, which is in the back. If you don't see a decimal, it's always in the back. We're going to move it over so that it comes to the first number that's between 1 and 10. So we're going to go 1, 2, 3. And now our number that we're going to rewrite out, we're going to write out the first part, which is 3.2. We don't need the zeros here. We're going to write it as a power of 10 times 10. And that 3 that we moved, so my answer is 3.2 times 10 to the third power. Okay. Now, what happens if we have a very small number? Well, let's rewrite it. So I have this number right here, and now I'm going to take this number and move it to the first number that's between 1 and 10. So our first number between 1 and 10 is going to be 5. 1, 2, 3. So I'm going to rewrite this. 5.61, because that's where I move that decimal. Then I'm going to multiply it by a power of 10. Now, if you noticed, I had a very, very small number. Okay, I'm also moving it basically in the opposite direction of this. So which means my small number is going to make it a negative, and I moved it 3 times. Okay, so writing in scientific notation, make sure that you have the first part, that the first number is between a number of 1 and 10, and the second part is you are multiplying by that power of 10. Alright, so what are the 2 parts of the scientific notation? We just kind of covered that right now. Alright, final. We're going to compare and order numbers in scientific notation. The first thing that we're going to do here is we're just going to list by the powers of 10. So I want you to go ahead and make sure that you circle all of these powers. And we're going to go ahead and use your basic number line rules. The larger the negative, the smaller it is. So we're going to go ahead and put them in small to biggest order. So first of all, we're going to go ahead and look at these. And looking at this, we have 1, 2, 3 of them. That's all negative 3s. However, if you're looking at the order of these, let's start with the smallest number. Then the next one is going to be 1.32. Okay. Then the next one is going to be 3.12. And again, I've started off with numbering these because these are the smaller of our negative numbers. Then our next one is going to be -1, so that's going to be 2.13. then we now have 1, and then we have 2. So again, you're going from smallest to biggest just by using your powers. Okay, so you're going to group by powers. And then, so our next one after this would be that 1, so it's 2.13 times 10 to the first power, and then finally you have 3.12 times 10 to the second power. Alright, so just to recap on this part, we now have that you need to make sure that you are lining them up according to the exponential power. Since I have 3 negative 3's, I'm going to line them up according to the lower number. So that's the smallest one, that's the next smallest one, and that's the third smallest one. Okay, so it goes boom, boom, boom. And then from here, you're going to go negative 1, 1, and then 2. Again, you're basing it off of that power of that 10. So just to recap everything else, your scientific notation is going to be a two-part number. You have your number that is between 1 and 10, and then you're going to multiply that by the power of 10. And don't forget, the way that you are writing these, you have to make sure that you understand that if it's going to be a negative exponent or a positive exponent. Negative exponents are going to be your smaller than 1 numbers, and then your positive exponents are going to be bigger than 1 numbers. Okay? So, at the end of this, you should be able to tell me why 34.1, 34 and 1/10 times 10 to the negative 2 is not written in scientific notation. Just by looking at this, you know that something is wrong. Okay? Alright. So, if you need more information, or you'd like to review any other videos, I want you to go and visit www.youtube.com/user/TycoDad, and thanks for watching.